Hello everybody, welcome back to Higher Maths. Today we start a new topic. Excited. It is sets and functions. We start with a lot of housekeeping. Apologies, this is going to be rather dull, but it needs to be done. I'm going to go over some different symbols and what they mean, and also talk about families of numbers. Oh yes, grab some popcorn. Right, first things first, this silly looking E symbol means is a member of. For example, if we look at this little set of numbers, 1, 2, 3, 4, I can say that 4 is a member of this set, because it's there. I could say 1's a member of the set, or 2, or 3, or 4. But the key thing is, this little symbol means is a member of. Next thing. Well, if you can be a member of it, then you can also not be a member of it. Okay, so for example, the wee E thing with a line through it, that means is not a member of. So if I look at this little set of numbers, 1, 2, 3, 4, I can say that 5 is not a member of that set of numbers. Next thing. Like the camera's so bored it fell off. Next thing we have the empty set. Ooh. So our wee brackets in here, they're not like normal brackets. You might have noticed that up here in the sets. They're kind of dodgy wee brackets. If there's nothing in there, it means the empty set. An example of that, the set of square numbers between 10 and 15 is empty. There are no square numbers between 10 and 15. The square numbers go 1, 4, 9, 16, 25 and so on. So when we have the brackets with nothing in it, it means you have an empty set. Next thing. Subset. Subset means part of a set. So for example, if we have this set of numbers here, 1 to 10, I could say that 3, 6 and 9 is a subset of that list. Okay, so we've got, to recap, is a member of, is not a member of, empty set, and an explanation of what subset means. Now it's talking about types of numbers. The last time you really discussed types of numbers was way back in primary school when you talked about odds and evens. Different families of numbers. Here we go with other families of numbers. We have something called natural numbers. Natural numbers start with 1 and go 1, 2, 3, 4, 5 and they keep on going. Whole numbers. Whole numbers is very similar, except whole numbers also include a 0. Integers. Integers is next. Integers again builds on that. Not only does it have 0 and all the positive numbers, but it also includes your negative numbers. We're always building on the last set. So this started 1, 2, 3, 4, 5. This added in a 0. This added in the negatives. The next one is what we call rational numbers. It's given a letter Q. It's a set of all numbers that can be written as fractions. So in here we were only talking about whole numbers, okay? But now with Q, with rational numbers, we also add fractions into that as well. We're only missing one type of number, so we've got one more family of numbers, and that is real numbers, which is given the letter R, and that includes all of these numbers, but it also includes rational and irrational. So root 3, surds, and that is all the different families of numbers that we've got. This one down here, real numbers, that's the most important one. That's the one we usually work with because it includes basically all numbers in the world. Okay? Right. One other little thing. The domain. The domain. For example, if I have a function 4 over x, okay? What I could say is that x could be any real number, but there is a number that if we pop in there instead of x, this whole thing stops working. You might remember, we've talked about this previously. This is 4 divided by something. There is a number that goes in there which will give us, well, it will make the calculator stop working. Can anybody remember what it is? That's right. Well done. It is 0. We do not want x to be 0. We never want the bottom of a fraction to be 0. So what I can say here is that x can be any whole number, x can be any real number, but it cannot equal 0. We don't want it to be 0, because if it equals 0, it stops this from working. Right, that's just a bit of maths geekery for you there. Do you really need to know all of that? Well, it helps a little bit, but it's not really going to be in the test, is what most people would be wondering about. So, what will be in the test? This topic, a lot of it is to do with what we call functions. Okay? Now, here, I'm saying for each pair of functions, write a formula for h of x equals f of g of x. That's how we pronounce that. So I have given you 2 functions. I have given you f of x, which is x add 3, and I've given you g of x, which is called 5x. Now you might be wondering, where on earth have all these letters come from? Well, this is easy. F of x, I have a function that contains the letter x. It's x add 3. I've got another function, so I can't use the letter f again, so this time I'm just going to go with g. G of x also stands for, I have a function that involves the letter x. And it involves the letter x because this thing says 5x. If this thing had said y, it would have to be g of y. If it had said z, it would have to be g of z. What I'm looking to do here is I'm looking to create a new function, which I'm calling h of x, because f and g had already been used. And I am going to attempt to put g of x inside f of x. Sounds a bit weird. I'm going to attempt to put this thing here, g of x, inside this thing here. So this letter x is going to be replaced by this whole thing. Now, how I write that out is I would say, well, it's f of g of x, so I'm going to do f of 5x. This is what the g of x thing is, so that's how I would write out my kind of next line. That's going to equal, now remember, I'm going to write this thing out, but I'm replacing the letter x with this thing here. So I would get, I'm not writing x, I'm not allowed to write it, I'm going to write that thing there. So I'm going to get 5x plus 3. Now, in terms of the notation here, this is calling h of x. It's 5x add 3. So I'm putting this thing inside this thing. Let's do another example of that. Okay, again, I'm trying to do f of g of x. Let's just skip straight to h of x. Let's not bother with this f of 5x step. So I am putting this thing here inside this thing here. So I'm replacing the x with this. So that would give me, writing this thing out, 5, and then it's not x, it's now x squared minus 2. Job done. Right. You try question 3. In fact, no, I'm talking nonsense. I'm not ready to let you try it yet. You haven't learned enough, young Skywalker. Right, number 3. Again, I want h of x, which is f of g of x. So that thing there is going in there. I'm replacing the x with this thing here. So that would be 6 cos x. Last one on this type, question 4. Again, I'm going to do f of g of x, which I've called h of x at the start of the question. I'm going to substitute this thing here in here. This is a wee bit harder this time because I've got 3x squared. So I'm going to have 3, and then I'm replacing the x with the x minus 2. This is multiplying together, so I'm just going to put it in a bracket. And then I've still got to square it. So that will go on the outside of the bracket. there's no need at this point to square out the bracket and kind of simplify things. I'm just going to leave it like that. So that is how you do f of g of x. You're putting the g of x thing in over here instead of the x. Now, I'm going to swap it round a little bit. This time, we're going to create this new function called k of x. F, g and h have already been used. And this time, it's going to be g of f of x. Last time it was f of g of x. This time it's the other way around. So this time the f of x is going to go into the g of x. Now what I want to do is I just want to write out, I'm using the same as what we used over here on question 1. It's the same f of x and g of x, right? So it's k of x equals, this time it is the f of x that is going in there. So it's the same as what we did previously, it's just the other way around. So the thing f of x, the thing in this bracket, I always put in a circle and I arrow it over to the other x. And then we write out this one. So I've got 5, and then I've not got x anymore, I've got x add 3. So in a wee bracket, this one's easy, let's just multiply it out. 5x add 15. The second one, we had f of x was 5x minus 2, and we had g of x, which was x squared. And now we're going to work out what k of x is. So it's g of f of x. So the f of x is in the bracket, so that goes in the circle and it arrows over to the other x. I'll write this out. So instead of writing the x, I'm going to write 5x minus 2. I'm going to pop it in a wee bracket because I can see that I need to square this thing at the end. I can square it out if I want, or I can just leave it as it is. I'm lazy tonight, so I'll leave it as it is. Number 3. We had f of x equal to 6x and g of x equal to cos x. We're going to work out k of x, which remember is g of f of x. So that's the bit in the bracket, so it goes in the circle and it arrows over and replaces the x in the other part. So this would give me cos, no longer x, cos 6x. Last one before you do some work. So I've got f of x equal to 3x squared. I've got g of x equal to x minus 2. K of x, this is it's g of f of x, which I had at the start. So the f of x is in the bracket, so it goes in the circle and we arrow it over and replace that with it. So as I write this thing out, that x is gone, it's been replaced by 3x squared, and I'm left with a minus 2 also at the end. That, people, is how you do f of g of x and g of f of x. Remember, the thing in the bracket is the thing which goes in the circle, and you arrow it over and replace the x with it. Over here, it was g of f of x, so the f of x is in the bracket, so it goes in the circle, and we arrow it over and replace it in here. You're going to try. So same as what I did there. This side I want f of g of x, and this side over here I want g of f of x. So it's up to you how you want to tackle this, if you want to try them at the same time. Let's do that at the same time. So your number 1, you've got f of x equals x add 8 and g of x equals 6x. Over here I would probably want to see it written out again, because that's how I've taught you. Like so. Hit pause, give me f of g of x and give me g of f of x. Go. Okay, so f of g of x, so this is h of x, that's what we're calling this new function. So the g of x is in the bracket, so it goes in the circle, and we arrow it over and replace that x with it. Remember, it's replacing it, it's not multiplying it, it's replacing it. So let's write this out. X is gone, it's been replaced by the 6x, and I've got an add 8 still as well. Job done. Over on this one, I want g of f of x. I'm going to call this k of x. So g of f of x, the f of x is in the bracket, so it goes in the circle, and it arrows over in place of the x. I'll write this out, so I'd have 6 multiplied by x add 8. Leave it like that if you want, tidy it up if you want, it doesn't really matter to what we're doing. Hopefully you got both of them right. Right, question 2. We've got a 3x minus 1, that's our f of x, and g of x is x squared. I'll write it out again on this side because I want to see both of them for both types. So on this side here, I want you to do f of g of x, and on this side here, I want you to do g of f of x. Hit pause, give it a go. Okay, so this one here, we're calling this h of x, this new function. It's f of g of x, so the g of x is in the bracket, so it goes in the circle, and it arrows over and replaces that with it. I'm going to write this out. I'm going to get 3x squared minus 1. Over on this side, the new function is called k of x. So it's g of f of x, so the f of x is in the bracket, so it goes in the circle, and it's going to arrow over and replace the x. So as I write this out, that's gone. It's been replaced by 3x minus 1, and I've got to square the whole thing. I'm just going to leave it, I'm not going to bother squaring it out. Right, question 3. F of x equals 4x, g of x equals sine x. I want you, again, to do the same thing. I want you to do f of g of x, and I want you to do g of f of x. Hit pause, on you go. Right. So this side here is h of x, that's what we're calling this new function. It is f of g of x, so that g of x is in the bracket, so it goes in the circle, arrow it over, replace the x with it. Write this out, it is 4, that's gone, it's been replaced by sine x. The other side, the new function is called k of x, it is g of f of x, the f of x is in the bracket, so it goes in the circle and it arrows over and replaces the x with it. Write this thing out, sine, it's no longer x, sine 4x. One more for you to try. F of x equals x squared, g of x equals x add 1. Remember, on this side I want you to do f of g of x, and on this side I want you to do g of f of x. Hit pause, give it a go. Okay, so this side, the new function is called h of x. So it's f of g of x, so the g of x is in the bracket, so it goes in the circle and it arrows over and replaces the x with it. Write this thing out, the x is gone, it's been replaced by x add 1, and I've got to square it, which is why I popped it in a wee bracket. On this side, it's the f of x that's in the bracket, so it goes in the circle, arrow it over, it replaces the x. When I write this out, the x is gone, it's been replaced by the x squared, and I've still got the plus 1. And that is how you do f of g of x and g of f of x, which is usually quite a popular exam question. Right. Another little bit for you. This time, this is going to blow your mind. I'm giving you the function f of x, which is x add 3, and I want you to work out f of x. That's right, people, you're going to put the function back in itself. To do this, the method that I use, like previously, I want to see this written out twice. So I've got f of x equals x add 3, f of x equals x add 3. I'm going to put this one in the circle, and I'm going to arrow it over and replace that letter x with it. It's very similar to what we've just done, but some people get a wee bit confused by it. So f of x equals, that's over there, write this thing out, the x is gone, it's been replaced by an x add 3, and I've still got an add 3. Tidy that up, that is x add 6. Let's see that again. This time I've got 2x minus 1 as my function. Again, I want f of x, so the method that I like to use is to write it out twice. We're going to put that one in the bracket, so that one goes in the circle and it arrows over and replaces that letter x with this whole thing. Write this thing out. I've got 2 the x is gone, it's been replaced by this thing here. They're multiplying, so I need to pop it in a little bracket, and I've still got the minus 1 at the end. Multiply out the bracket, I get 4x minus 2, and I've still got my minus 1 at the end. Tidy that up, that is 4x minus 3. Job done. That's how you do f of x. Your turn to try it. So first one, your function is x minus 4, and you've got to do f of x. So I would want you to write it out twice. Circle, arrow, do your answer. Hit pause, on you go. So f of x equals x minus 4. F of x equals x minus 4. That goes in the circle, arrow over, and then we're good to go. It is known internationally as the circle arrow technique, and that has been trademarked by me. So if you use it, I can sue you. So this thing here I'm going to write out, the x is gone, it's been replaced by x minus 4, and then we've still got this minus 4. So that's going to give me x minus 8 as my final answer. Right, next one I want you to try. Same again, write it out twice, circle, arrow, get your answer. Hit pause, on you go. Okay, so f of x equals 3x add 2. F of x equals 3x add 2. That's in the bracket, so that's in the circle, arrow over, replace the x with it. So f of x is going to equal, write this thing out, so I've got 3, the x is gone, it's been replaced by this thing over here, they're multiplying together, so I need a bracket, and I've still got this add 2. Multiply out the bracket, that's going to give me 9x add 6 add 2, so my final answer is 9x add 8. I hope you got it right. Right, one other thing I want to show you, because I've got a funny feeling that the exercise you might be doing with this with your teacher involves something that looks like this at the end, which is a really kind of complicated one, which involves a right nasty fraction as well. Okay, so I'll work through this. I'm not going to set you this. You can use this example to help you with the work that you'll probably do in the textbook. So I want f of x, so again I'm going to write it out twice. And as I said, this is nasty because of the fractions involved. Circle, arrow. Now, this is the first time we've come up against something like this. There isn't just one x on this side, there's two x's. It has to replace both of them. It's the first time I've come up against that. Usually this is the one x, but if it's got two x's, three x's, four x's, it's got to replace all of them. I am now going to attempt to write this thing out, but with this thing substituted in its place. F of x is going to equal, right, so I've got 3 add, not that, I've now got this big huge thing over here. So I've got 3 add x over x, and that is all on this top line of the fraction, over x has been replaced by this whole thing again. See what I mean? Horrible. Right, we are trying to divide something by a fraction. Okay? I know how to divide something by a fraction. I hope you know how to divide something by a fraction as well. You change the symbol to times and you turn the last one upside down. The problem is actually this thing here. I want this top just to be one fraction. The fact that I've got this 3 here at the start is going to make life really difficult for us. So what I need to try and do is I need to rewrite this 3 so that I can combine this as a fraction. So basically, instead of it being 3 over 1, I would want the bottom of this fraction to say x. To change this, I am allowed to multiply. So if the bottom of the fraction is 1 and you want to turn it into an x, the thing you need to work out is what do you have to multiply by? And the answer is x. Okay, let me just write it to the side. I've actually got 3 over 1 add 3 add x over x. That's what I've actually got there. I want this to be the same as this on the bottom, so I'm going to multiply this side by x. Whatever you do to the bottom, you do to the top. That would give me 3 times x, 3x. Bottom line, 1 times x, x. And this thing here I've still got is the same. Except this time I'm adding the fractions together and the bottom bits both say x, so I can combine these two fractions together. If I do that, 3x add 3 add x, that's going to give me 4x plus 3. And on the bottom line, remember when you're adding fractions together, you know, if this was quarters and we add quarters together, the bottom number would still stay as a 4. So the bottom thing will still stay as an x. So what I've done is I've rewritten this top line of the fraction like this. Believe it or not, that actually helps us. So I'm going to come back over here and I'm going to say that f of x equals, the top line is no longer this, it's this thing over here. Instead of having it as a divide line, I'm going to write it as a divide symbol. Then I'll have this thing here. Right, I said before, I'm trying to divide by a fraction, which means we change that to times and we turn that one upside down. Change it to times, that turns upside down, and we get this. Now, how do you multiply fractions together? You times the tops and you times the bottoms, but hopefully you remember how to do something called cross simplification. This x and this x will cancel out, leaving basically a 1 on both sides. Which means when I times this together, I get 4x add 3. And when I times the bottom bits together, 1 times that, I get 3 add x. Now, if I wanted to write a suitable domain for this, which links us all the way back to the start of the lesson, a suitable domain, x can be any real number apart from, remember, we never want the bottom of a fraction to equal 0. Never. So the number which makes the bottom of the fraction equal 0 is a number we don't want x to be. X cannot equal what makes the bottom of this fraction 0. What do we replace in there that turns the fraction, the bottom line, to a 0? Yes, that's right, minus 3. We do not want x to be minus 3 because it stops everything from working. Right, so we've had set notation, we've had f of g of x, g of f of x, f of x, and also a rather nasty one with a fraction involved in it as well. That is all for today. I'll see you next time.